Assalamualaikum. My name is Wan Muhammad Azfar Safan Bu Ahmad. Okay, I want to present about introduction. Conventional machining are also known as traditional machining, which having the meaning of the process of removing the material by performing manually or by skill and knowledge by machinists. Conventional machining mostly remove material in the form of chip by applying force with a wedge sharp cutting tool that harder than the work material. There are three principles of machining processes, which consist of turning, milling and drilling. Turning process can be explained by the material is rotated and the cutting tool move toward the material and started the material removal process. Milling process is opposite to turning process, which is the cutting tool is rotated and the material is fixed. But both turning and milling process have the same characteristic, which is both process are feeding process. Feeding process having the meaning of cutting tool is feed to material and started the material removal process. Drilling process is similar to milling process, but drilling process is only for hole making process. Next is objective. First, to understand the QC tool used in analyzing the defect found in the conventional machining process. Next is to identify the defect of the product from the conventional machining process. Next is to analyze the defect of the product from conventional machining process in terms of the least defect cost of the machine to the production. Next is to improve the process and find the best way of the tool or technique or process that can be implemented to reduce the defect from both of the machine. Next, to improve the process both of the machine by implementing the quality tool that has been analyzed can reduce the defect of the product. And the last one is to learn the method of construction the QC tool by using Minitab software.
Hi, Assalamualaikum. My name is Nick Muhammad Haziq bin Nick Amran and my ID is 18131251. As my part, I will explain about methodology. Basically, check sheet, scatter diagram, cause and effect diagram, and Pareto chart are classified as the 7 quality tools that use for identify as well as collect and analyze data. The 7 quality tools, also known as 7 QC tools. Process flowchart having a meaning of schematic diagram that shows the flow of process or a research as it moves through the various processing station or an operation. There are 3 typical graphical shapes introduced in process flowchart, which are the rectangular, diamond as well as the oval shape. A team construct flow diagram is classified as the best compared to one individual to understand the entire process. A standardized symbol are used in this research paper. Begin with the brainstorming with group members regarding about the type of defect occur during after the machining process. The improvement to the process can be accomplished by eliminating steps, combining steps, or making frequently occurring steps are more efficient. The graphical represent of the process flowchart is shown as figure. Next, diagram analysis is the explanation of the result from graphical representation, such as explanation of the trend of the control chart. Pareto chart analysis, the correlation of the scatter diagram, and so forth. Next section would be the acceptance of the data. Next, cause and effect diagram was known as the Ishikawa diagram, which has been developed by a Japanese organization theorist so-called Professor Kaoru Ishikawa. The cause and effect diagram are namely as fishbone diagram due to its design look like the skeleton of a fish. The highest number of cutting defect was identified. The problem was wrote down to the right side that act as the head of the fishbone. A straight arrow was drawn from the left toward the problem. Major cause is identified and placed on the diagram. Basically, the major cause of problem are environment, man, material, machine, method, measurement, or known as the 5M1E. Next, Pareto chart determine the method of classifying the data by problem, cost, type of non-conformity. Decide if $best weight frequency or frequency is to be used to rank the characteristic. Collect data for an appropriate time interval. Summarize the data and rank order categorized from smallest to largest. Compute the cumulative percentage if it's to be used. So this method for constructing the QC tool, the development of the Minitab software allow the construction of the QC tool as well as the data contribution diagram. Basically, the Minitab software considered as the statistical software whereby it applied for analyze data effectively. It also used for solve the toughness business problem. The application of Minitab not only in engineering field but also in other field.
Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Muhammad Syahir bin Kamarul Anwar and my metric number is 181312944. I would like to continue the presentation slide about data analysis and manufacture part. Okay, data analysis. From our data analysis that been collected through experiment process and methodologies that been used from the 7 QC tools, we determine what's the types of defects that occur most of the manufacture parts done by conventional machining industry. From the result that we obtain using Minitab software and the type of defect is using cause and effect diagram, so we can arrange which is the most type that occur. Okay, as you can see from this slide, there are 4 types of defects that have been selected from the results, which is the first one is formation of the burrs, which have occurred in 62, and rusty workpiece or rusty product occur in 20 units. Nail holding is 19 units and tool failure is 3 units. This data result is obtained from the research paper, and from that data we calculate the percentage and also the cumulative percentage. The arrangement is based on from the highest of the percentage into the lowest of the percentage, but the cumulative percentage is the addition of every percentage. So next slide, as you can see the Pareto diagram, which the highest of the types of defect is formation of the burrs and the rusty formation on the workpiece. Third is the nail holding, and lastly is tool failure. And you can see that around 56.61% defects happen on the formation of burr, while others is caused by 3 defects, which is rusty, nail holding, and tool failure. So the conventional industry need to solve the formation of the burr to increase the quality of the product. Okay, next slide will show example of part that usually being produced in conventional machining industry. As you can see, this 3D model sketch is a motorcycle bar balancer, which locates at the near end of motorcycle. Okay, from this 2D sketch, you can see that formation of the burr can be happen during the tapping and drilling in the middle of the workpiece. The formation of the burr can also occur on the shaft, the end of the shaft, and also the upper end of the shaft. Okay. Yes. This is to show how most where location that this type of defect occur. Okay, that's all from me. Thank you.
Hello, my name is Ron Violin Sajang Anachungat, and today for my group I will be presenting about the discussion and recommendation. So let's get into it. So for our discussion, as you well know, quality or quality control is one of the activities and technique that applied to achieve and maintain the quality of product, process, and or service. So quality control is very important. It's a way to maintain a high standard of product, process, and service. Now, quality system or quality control also help eliminating cause of quality problem. So every product, every process, every service, there will always be a problem, and quality control help to eliminate or minimize the quality problem. And next is quality control inspect the product at the end of the manufacturing process. So quality control in manufacturing usually inspect every product that has been finished processing to inspect any default, any rejected parts. And then 4 types of quality control tool that has been used in this research which are cause and effect diagram, Pareto chart, check sheet, and scatter diagram. This is the 4 types of QC control that was used in our project. So used to identify the highest defect and propose to suitable solution. So we use this 4 type of quality control tools to identify highest defect and the purpose or to find the suitable solution to reduce or eliminate this highest defect that has been detected. Okay, next would be the recommendation. So for our recommendation, that the highest number of defect must be overcome first compared to the other types of defect. So as we will know that we usually list out the most highest defect, and as you can see, the highest defect should always be the first priority. So it can be reduced or eliminate altogether. Next is the implementation of the QC tool is for analyzing and identifying the problem occur in a process or a product. So QC tool should be implemented so we would know and we would analyze any problem or anything that makes a product be rejected. And that is it from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So today I would like to present to you about the result and discussion. So as the result, the defect that we have found in this project is burst formation. Burst formation defect classified as the highest frequency defect that found in conventional machining. So in in this project we choose conventional machining, which is using the lathe machine. The product that we proceed with the lathe machine. So what the cause of the burst is, number one is the physical characteristic of the material. Because the physical material is ductile material. Number two is the depth of the cut. The solution to prevent burst is provide the sufficient training for the operator, so the operator can adjust to avoid the burst during the machining. So in this discussion we use fishbone diagram and Pareto chart to illustrate the result. So why we use the diagram? Because of to identify the highest defect and propose the suitable solving to solve the cause, and to show how to prevent the defect. So that's all for me. Thank you.